Hi, Pre-Algebra students. Here are your notes for lesson 610. This lesson is all about using angle measures to determine whether two triangles are similar. So let's start by talking about this word similar. Remember, we said that congruent, which uses this symbol, means exactly the same, whereas similar is just a little squiggly, and remember that means that two figures are the same shape but different size. We also talked about two ways that we can determine if two figures are similar. So here we're trying to prove today that two figures are similar by using what's called the angle-angle criterion, which basically states that we can prove that two figures are similar by proving that two angles are similar. Because remember, we said in order to be similar, we said sides must be proportional. And angles must be congruent. Okay, so when we look at these two triangles right here, triangle ABC and triangle DEF, we can see that they appear to be the same shape but different size. When you look at those angle measures, we want to pay special attention to those symbols in the corner by the angle measures. So when you see those little red arcs, one arc means that these two angles are similar. So they're telling you, I'm sorry, not even similar, they're telling you they're congruent. So angle A is the same as angle D. Okay, they are exactly the same measure. And then where you see two arcs in the top, angle B is the same as angle E. Okay, so this angle is the same as this angle. They are exactly the same measure. And if we can prove that two angles are the same, then by default, the third has to be the same also. So that's why we only need to make sure we prove two. So let's look at example one. This says, are these triangles similar, and explain. So first of all, we can see that we have two triangles here. They are sitting in pretty much exactly the same orientation. So when we look at angles, we want to think about corresponding angles. So when I look at this figure, I can see that angle A corresponds to angle M. So I would say that angle A is congruent to angle M because they both have a 70-degree angle measure. When I look in the lower right-hand corner, I can see that angle C corresponds to angle P. So I would say angle C is congruent to angle P because those two angles both measure 50 degrees, okay? So we basically were looking for those two congruent angles. So if two angles are congruent, then the figures are similar. Okay, so what we would write for this is we would say like this, triangle, we use a little symbol triangle, A, B, C is similar to triangle M, N, P. Okay, and if you notice, I went in the same order with the letters, like angle A corresponds to angle M, so those go first, and then B comes second, so N goes second, and then C goes third, so P goes third. You want all those letters to be in the same order so that those corresponding angles match up. All right, so Let's look at number 2. Number 2 says, are these triangles similar? So this time we have two triangles, but they're not in exactly the same orientation. So we want to think back to our conversation earlier in the unit when we were talking about transformations. Like, how could we get this second triangle? I'm going to put an extra letter here. I'm going to call this one RST. Okay, so how can I map triangle RST onto triangle XYZ to see if they are similar? So I can see that they both have one congruent angle measure right here. So I know for sure that angle Y has to correspond to angle T because they are the same measure. So I would say angle Y is congruent to angle T. So when I think about turning that, I want to think about, is the 42-degree angle going to match up on top of the 45-degree angle? So one other thing I can do if I'm not sure is use what we learned about the sum of the degrees in a triangle to help me determine if there's another congruent angle measure. So I can say, if I'm looking for, let's say, this angle down here in the corner, I can say, does 42 plus 85 plus that missing angle measure equal 180? Okay, and then I can find that missing angle measure. So if I add these two numbers up, I believe that is, I'm going to call that missing instead of the question mark. I'm just going to put an X there, and then I'm going to add 42 and 85, which is 127, I believe. And if I set that equal to 180, and then subtract 127 from both sides to find the missing angle measure, that means that the third angle in the first triangle has to be 53 degrees. Okay, so if I know that they both have an 85-degree angle, but the first triangle has a 42-degree angle and a 53-degree angle. So I could also double check this one over here and say, okay, I'm going to add 45 plus 85, and then I'm going to call that missing angle measure X. So if I add the sum of those two, I get 130. And then subtract that from both sides. Okay, so now I just proved that this third angle measure over here is 50 degrees. So I can see that now that I know the three angle measures in both of those figures, then I would say that no, they are not congruent because they only have, sorry, they are not similar. They only have one congruent angle. Just to be clear, I'm going to say not similar. All right. Let's try one more of those. So we're going to go to number 3 here. And again, we're going to say, are these triangles similar? And explain. So again, we're looking for two congruent angles. Okay, always two. 2's our magic number. And I can see right now that I have one congruent angle right here. So I would say that this angle is congruent, okay, because they both have a 46-degree angle. There's no label there, so I'm just going to say those two angles are congruent. Let me fix my symbol. Okay, so again, if I think about my transformations, I know that this angle right here in the corner, this is a 90-degree angle based on that symbol. And if I were to rotate that figure, it looks like that 90-degree angle is going to land right in that corner if I match those 46-degree angles on top of each other. So what I want to check to see is if I use the sum of the angle measures in the triangle, is this indeed, I'm checking to see, is this angle measure here 90 degrees? So if I add up those first two angle measures, the 44 plus 46 degrees, and then call that missing angle measure X, let's get a sum here. So it looks like that is 90. And then if I subtract that from both sides, okay, I just proved that indeed this missing angle measure is 90 degrees. So by default, that means that they both contain a 46-degree angle and they both contain a 90-degree angle measure. So I would say, yes, they are similar because they have two congruent angles. Okay, and again, 2's our magic number. All right, so something new in number 4. So now that we know how to prove if two figures are similar, now we're going to use the idea of two similar figures to find the missing angle measures, again, based on some of our learning in the beginning part of this unit. So looking at this figure in number 4, I can see that I've got these two triangles and they're telling me here that they are similar. So I'm not proving it, I'm using the fact that they are similar to find the value of X, okay? So one of the things I remember from the beginning part of the unit is that these two angles right here that are across from each other, okay, then I'm showing you the little blue arcs, okay? Those are what we call vertical angles. Remember, vertical angles are when they make the little X and then the angle is like across from each other here and here. And remember, we said that vertical angles are always congruent. So if that's a 90-degree angle in the small triangle, then I know for sure that it is a 90-degree angle in the big triangle, okay? So I know that's 90 degrees. I also know that this angle in the corner is labeled 15x, and they're showing me in the little triangle, again, look at these two marks here and here in the corner. So that's telling me that those two angles in each of those corners is congruent. So if the measure of the angle in the big triangle is 15x, then this angle also has to be 15x. And again, if you think about our transformations, if you were to reflect the little triangle on top of the big triangle, those angles would land on top of each other. Okay, so now using what I know about angle measures in triangles, I can add up all three of those angles, 15x plus 90, and it should equal 180. I'm going to combine my like terms. So that gives me 30x plus 90 equals 180. Using good equations work, I'm going to subtract 90 from both sides. So 30x is equal to 90, and then divide both sides by 30. So x is equal to, let me make sure I check my math here, 90, 30. X is equal to, that is not right, sorry, I said 30 and it should be just 3. X is equal to 3, that sounds better. Okay, so x is equal to 3. I'm going to zoom in so you can see that a little bit better. All right, and that's all they asked me to find is the value of x. If I was going to find the missing angle measure, if they said, what is the measure of the angle in the corner, I could take that 3 and substitute it back in place of x. Let me fix that. 15 times 3 is 45. So that means this angle here is 45 degrees, and this angle here is also 45 degrees. And then I could check that by adding 45 plus 90, which does indeed equal 180. All righty. Let's keep going. I'm going to, let's see, I'm going to go to number 5. I guess we'll do number 5 really quick. So look at 5. Again, this one's a little tricky. So we've got these angle measures here. Okay, so we've got these two triangles. And one thing that I do notice is that this is a nice straight line. Okay, so remember that a straight angle has to equal 180 degrees. And remember, those two angles that are sitting right there, those are called adjacent angles. They are right next to each other. And adjacent angles are supplementary, so they have to equal 180 degrees. So if I do 2x plus x, that has to equal 180. Combining my like terms, 3x equals 180, and then if you divide both sides by 3, x has to equal 60, okay? And actually, I'm just double checking because it says find the value of x if the two triangles are similar, and that is technically all it asks me to do is find the value of x. So even though I have all of these other labels in there, like the 3y, I don't need that. I don't need anything else. I just need that. I could check that if I wanted. If I know, I think that measure in the corner is 84 right here. So if I wanted to check that, I could do 60 plus 84 plus x equals 180 and find the measure of this missing angle up here, angle D. So that would be 144 plus x equals 180. And then subtract 144. So x would equal 36 degrees. So this would be a 36-degree angle up there in the corner. But you know what? I don't even think they asked me to find all of that. All right, let's go to number 6. This one is, again, we're back to like, are these two triangles similar? Is triangle QRS similar to triangle QLM? Okay, and these are just a little bit different. Sometimes we see it's like a figure inside a figure. So the little triangle here is triangle QRS, and then we have the big triangle here, which is triangle QLM. Okay, so one thing that I'm noticing is that they both share a right angle in the corner, okay? And then think, how many angles do I have to prove to determine if they're similar? And remember, I have to prove that two angles are similar. Well, I can see that they share the right angle, but I can also see that both of them share this angle up here in the corner, angle Q, okay? So I can say angle Q is congruent to angle Q. It's the same exact angle, okay? And angle R is congruent to angle L, okay? So I would say, yes, they are similar. They share two congruent angles. Okay, I'm going to keep going. I know this is a kind of a long lesson, but I want to make sure we get to these last two really quick. Number 7, are these triangles similar? Yes or no? And what is the value of x? Okay, so remember, I actually have to do two things in this one. I have to first determine if they're similar, and then I have to find the value of x. So one thing I'm noticing right away again is that I've got this nice straight line right here. And remember, straight lines have a measure of 180 degrees. So that means that if I take these angles here, they have to have a sum of 180 degrees. And there are three of them, this angle, and this angle, all three of those little teeny tiny angles. So I want to determine what is the measure of those angles there. But let's see. Ooh, I see something I can do. I can use these two angle measures in the corner to find the measure of the missing angle right here in that triangle. So I'm going to do that first. So I'm going to add 56 and 76, and I'm going to call that angle in the corner here, I'm going to call that x. Okay, because remember, all the angles inside the triangle also have to equal 180 degrees. So if I add this together, let's see, 6 and 6 is 12. So 132, I believe that is. And then I'm going to subtract that from 132 from 180. So x is equal to, let's see, 48 degrees. Yep. Okay, so this angle right here is 48. Now, I still haven't found the value of x right here. So I'm going to add, I'm going to back up a minute because I just noticed something. I just noticed that this angle is now congruent to this angle. And the 76 degree angle in the first triangle is congruent to the 76 degree angle in the second triangle. So I just proved that the two triangles are similar because they have two congruent angles, which is my first job. Now I'm going to go ahead and finish finding the measure of x, or the value of x. So again, I know the value of those three angles has to equal, the sum, I should say, of those three angles has to equal 180 degrees. So I'm going to add 48 plus 48 plus 4x and set it equal to 180. So let's get this added up. 8 and 8 is 16, 4 and 4 is 8, 1 is 9. Okay, I'm doing a lot of mental math here, but if you need to pick up your calculator, you absolutely can. Okay, let's subtract. Oops, that was not good modeling. Let me get that 96 in the right spot. That should go under the 96 because that's what I'm subtracting it from. Let's see, 180 minus 96, 4 is 100, so that'd be 84. Divide everything by 4. Again, this is all just equations work, friends. Okay, so x is equal to 21, and that's my answer. So I did both of my jobs. I proved that the two triangles were similar, and I found the value of x. X is 21. So if I wanted to know the measure of that exterior angle, I could do 4 times 21, which would be 84, which would get me there. Okay, not what they asked, though. So I'm going to go ahead and move on, and we're going to finish up question 8. Are these two triangles similar? So again, in order to determine if they're similar, I have to prove two sets of angles are congruent, okay? So, let's see, if there's, they're asking me, are they similar? Okay, so I know that angle S is part of both triangles, so I know that angle S has to be congruent to angle S. So one thing I can do is set those two angle measures equal and find the value of x. So I'm going to go ahead and solve for x. I'm going to start by subtracting 3x. This is an equation with variables on both sides. So I need to combine all of my x's on one side and all of my constants on the other. Next step is to add 1, and so I can see that x is equal to 15. So if x is equal to 15, I'm going to use this value of x to substitute that back in and find the measure of those angles to see if they're congruent. So let's start with this guy right here. 4 times 15 is 60 minus 1 is 59. So that's a 59-degree angle. 3 times 15 is 45 plus 14, I'm doing this angle right here, is also 59. So again, I just proved that those are both 59-degree angles. Now I'm going to go to the two angles here and here. So angle T and angle P. Angle T, 15 plus 15 is 30, so this is a 30-degree angle. And angle P, 2 times 15 is also 30. So both triangles share a 59-degree angle and a 30-degree angle. So I'm going to say, yes, they are similar. Because they have two pairs of congruent angles. All right, friends, that was a lot of instruction. Okay, so please feel free to go back and review this video. You can, pause it anytime and look it over. It's a lot of information, a lot of equations work, a lot of ideas going on in here. So take your time and let me know if you have any questions.